All right, this video is going to be on compositions of inverse trig functions. And before we get started, I just need to remind you of something that you've learned before but maybe don't remember. And so first, I'm going to go ahead and draw the four quadrants. We're going to label something. So in the first quadrant, your x-coordinate and your y-coordinate both end up being positive. In the second quadrant, your x is negative while your y-coordinate is positive. In the third quadrant, both coordinates are negative. And in the fourth quadrant, your x is positive while your y is negative. And so the result of this is that in the first quadrant, all 6 of your trig functions end up being positive. In the second quadrant, the only positive trig function is your sine function and your cosecant function. In the third quadrant, the only trig function that's positive is going to be tangent and cotangent, because those are both negative, so we'd have to divide them to make a positive. And then in the fourth quadrant, only cos and secant are positive. So I've heard different teachers use different acronyms. I use all students talk constantly. I've heard all students take calculus. Whatever you want to do there is fine. So this is to help us remember which quadrants have positive answers for those. So if we're going through and we're trying to evaluate a composition of inverse trig functions, it's important to look at the information in the correct quadrant. So in the past, you probably stayed focused on values of inverse trig functions that showed up in the unit circle, and then you just made sure to look at the correct quadrants in the unit circle to find your answers. Now we're going to be looking at values that are not in the unit circle, and so that means that we have to draw a triangle in the correct quadrant. Since we are dealing with inverse trig functions, we have to make sure we're looking in the correct quadrants. So if you're just solving and you're using inverse trig in the process of solving, then you can look at all 4 quadrants. But if you start off with what is an inverse trig function, trig functions that are inverses have limited domains, and they have certain quadrants you can look in and certain quadrants you cannot look in. And all of this is stuff that you would have learned in pre-calc. So right here, quadrant 1 and quadrant 4, these are the only 2 quadrants where you can look for sine inverse and tan inverse when you know that you're talking about functions. Quadrants 1 and 2 are the only quadrants you can look in for cos inverse. And this is true for the other 3. So sine and cosecant, tan and cotangent, and then here would be cos and secant. All right, so inverses, you can only look in those specific quadrants. Okay, so now we're going to get into some examples, and we're going to be careful to make sure that we're looking in the correct quadrants for where we can draw things, and we're going to go ahead and evaluate. So my first problem that I'm going to evaluate is cos of sine inverse of 3/8. And I guess this fraction doesn't really need parentheses around it, but I drew it already, so. All right, so we look at the inside first. The inside is sine inverse. I know that sine inverse can be in quadrant 1 or 4. This sine is positive, and since I know that sine is positive in quadrants 1 or 2, that means I must be drawing something in quadrant 1. So I'm going to go ahead and start drawing my picture in quadrant 1. My angle is always the angle that is closest to the origin, and I know that sine is opposite over hypotenuse, so 3/8. All right, so I've set up my triangle. I'm going to go ahead and solve for the last side of my triangle. So I'm going to say 8 squared equals 3 squared plus, I'll just call it a squared. So 64 equals 9 plus a squared. And 64 minus 9 is 55, right? I feel very uncertain about that. All right, so that means that our a value is the square root of 55, and so I'm going to call this square root 55. Okay, so now they're saying take the angle that this one is referencing, which is cos, Sorry, someone knocked on my door and I have no idea where I was. So let me start that thought again. All right, so sine inverse of 3/8 is talking about the angle of the triangle. That is where this is the opposite and hypotenuse of that angle. So this is the angle that we're talking about. So sine inverse of 3/8 would just be theta, whatever theta happens to represent. So right there. So it could be like, gosh, I don't even know. It could be like 42 degrees or something, let's say. And then here, to evaluate this, we just have to find cos of that same angle. So we look at the triangle for that. Cos of that angle would be adjacent over hypotenuse. And so the evaluation for this problem is adjacent over hypotenuse, and that's it. So if we were to check this answer, we could type this whole thing in our calculator, making sure that we're in radians, or degrees, I guess it doesn't really matter. And we could type it in and our decimal would match up with this. So we'd get that same decimal there. Okay, let's try another one. So here, let's go ahead and we'll do cotangent of cos inverse, I do not need those parentheses, of -4/5. Okay, so for this one, we have a cos inverse, which means we're in quadrant 1 or 2. It can't be quadrant 1 because everything is positive there. So that means we're working in quadrant 2. So there's our angle. And we have adjacent over hypotenuse. So adjacent is 4, hypotenuse is 5. And when you're dealing with these problems where you have a negative, you have to think about which side is allowed to be negative. The hypotenuse represents like the radius of the circle if you're thinking in terms of a unit circle. And so the hypotenuse should always be positive because it's just the distance from the center. The 4 here is going to be negative because we went to the left. All right, we went to the left 4. Okay, so now we're going to go ahead and solve for that missing side. I've got 5 squared equals a squared plus -4 squared. So 25 equals a squared plus 16. If I minus the 16 over, I get 9 equals a squared. And so a equals 3. So that missing side right there is 3. So now if I say cos inverse of this angle right here, or of the fraction equals this angle right here, then cotangent of that would be adjacent over opposite. So adjacent over opposite is -4/3. And so this evaluation would be -4/3.